All right, let's jump back into it. So on 9.2, it's just solving linear equations, but now in the form of what they call ax plus b equals c. Basically, what this means is two steps. You'll try to get rid of the constant, which is the adding or subtracting first, then the multiplication division second. That's my approach to it, at least. It helps you avoid fractions until the very end, if there are fractions to be dealt with. So in our first example here, will be 2x plus 5 equals negative 21. Right? So again, in this process, what you do to one side, you must do to the other. And my recommendation is always to get rid of any addition or subtraction. It's a lot easier of a process. So in this case, what is the opposite of adding 5? So I'm now going to subtract 5. Again, what I do to one side, I will always do to the other. That will go away. And then I still have 2x. And now what is negative 21 minus 5? Negative 26. And if you borrow 21 bucks, borrow another 5, now you owe that kid or that person 26 bucks. Now I'm back to a one-step equation. A number next to a letter indicates multiplication. So how do I get rid of the 2? Now I'm going to divide. So what would negative 26 divided by 2 be? Take it as just 26 divided by 2 at first. So half of 26 is 13. And then since one's a negative and one's a positive, different signs give you a different sign, which is a negative. So we're good there? Right. Perfect. All right. So this next question, we have negative 18 equals 2y minus 8 minus 7y. So just like beforehand, before we can start doing things to both sides, we need to combine like terms first, which are the y's in this case. So what would 2y minus, so 2y minus 7y be? There it is. So negative 5y minus 8. Most students always ask me, does the order of this matter? Could I have written negative 8 and then said minus 5y? By all means, you can. I'm just so used to standard form, which is typically the letter and then the constant. Right? But I'm okay either way. They mean the same thing as long as you're keeping the signs with the numbers. So now I'm back to a two-step equation. What am I going to do first? Perfect. I need to get rid of my addition and subtraction. So I notice I have a minus 8. So I'm going to add 8, which is the opposite operation. So negative 18 plus 8 is, and I'm going to drop down my negative 5y. And now what would you do? Ooh. Good. So a negative 5 times y, so a number next to a letter indicates multiplication. So the opposite of that would be division. Oh, I got you. It happens all. We did this process 2 steps ago, and then so what would negative 10 divided by negative 5 be? Positive 2. Again, take the negatives out of it at first and go, all right, 5 goes into 10 2 times, and then stress about your signs. 2 negatives make a positive. Same sign equals a positive. Ooh, go away, search. We good there? All right. Here comes the decimals. So now we get 3.69 plus 12.8 z minus 6.25 equals 0. Again, before I can start doing things to both sides, I have to combine like terms. So in this case, what can I combine? Very good. The non-z's, right? I only have one thing that's a z, so I'm going to just drop it down. So I just have two things that don't have a z that can combine. Again, this is 3.69 minus 6.25. Again, if you stress about it, by all means, use a calculator. Will not hurt my feelings. And you get, see, 3.69 minus 6.25, and it'll give you the negative sign and everything that goes with it. All right. So in this case, it would be negative 2.56. So in this case, minus 2.56. Before I go on any further, are we okay with subtracting decimals with negatives and stuff? Perfect. So now what do? Perfect. Get rid of the addition and subtraction. Since I'm subtracting, I need to add. And what I do to one side, I need to do to the other. So I have 12.8z. And then now what is 0 plus 2.56? 2.56. Now what would be my next step? Good. Divide by the 12.8. And of course, what I do to one side, I have to do to the other. Now these numbers are getting kind of wonky. So again, I'm just going to simply come to my little calculator. Don't stress about the small stuff. Let the calculator do that part for you. So 2.56 divided by 12.8. We get 0.2. You can write the 0 if you want. I don't stress about the 0, but looks clean too. So we're good here. All righty. So just because there's decimals or fractions or whole numbers or whatever the case is, the process never changes. What the outcome looks like will change, but the process does not. All right. So let's do another decimal version. So number 4, we have 0.25x plus 0.5x minus 2.3 equals 1.45. What's my first step? Good. Add my x's, which is combining my like terms. So 0.25x plus 0.5x would be what? Very good. This is like 25 cents plus 50 cents. So I would have 0.75 or 3/4. So what would I do now? Perfect. Gotta get rid of that addition and subtraction. So I notice it has a minus 2.3. So I'm going to add 2.3. And again, you can type it, or you can do it by hand or type it in the calculator. Doesn't matter to me. So I'm going to do 1.45 plus 2.3 and get to 3.75. What would I do now? Perfect. 0.75 times x, that's multiplication. So now I need to divide. I'm basically trying to figure out how many 3/4 were in $3.75. So I'm going to take that 3.75 and I'm going to divide by 0.75. And I get 5 as my outcome. You still good? I know every day is going to be a lot, but we're trying to cram 16 weeks into 8 weeks. Yeah. I'm about to say graphs is where it just starts kind of doing downhill, but I'll show you some good techniques to help you out. But that's why the graphing calculator will come into clutch too. So you can graph it and then look at your calculator and go, all right, my graph looks the same. I know I'm doing it right. Oh, that was a lot. Yeah. Yeah, I teach a college algebra course as well, and it's a lot of content. But it gets intense. The kids were actually saying this class is super easy. Like in the first 3 weeks, I was like, just wait. And now they're like, let's go back to what we were doing. I was like, that's why we slowed down a little bit because I need you to comprehend some of these concepts. But here's one with fractions. Process doesn't change. So what am I going to do first? Oh, can I combine anything? Nope, but that's a good first step. What would I do next? 7/3, absolutely. So there, I'm subtracting by 7/3, so I'm going to add 7/3. And again, at this part, if you're using a Inspire, you can just go to a calculator thing. And this is what's really nice about these is I can hit this division bar right here. Oh, wrong one. I can do control divide and actually make the fraction. So it's kind of nice. And then you can just type in your -17 over 15. And then I'll just do plus, control divide again, make it a fraction, and then 7 over 3. Now, of course, we can do it by hand, but watch this. When I hit enter, not only does it give me the correct answer, but it'll always give me the simplified answer. So I don't got to worry about getting 12/10 as my answer and then having to reduce it down to 6/5. Right? Or would y'all like to see this by hand? Okay. Absolutely. Yeah. Any type of graphing calculator. Yeah. So it doesn't have to be the Inspire, it can be an 84, but I would definitely get some type of graphing calculator and you can use it on the test. All right. But to do this by hand, I have to look at my smaller number and go, how do I get 3 to become a 15? Times it by 5. But what I do to the bottom, I must also do to the top. So this now becomes 7 times 5, which is 35. And then 3 times 5, which is 15. So the denominators are now the same. So I just write 15, and now I do the operation. So that was -17 plus 35. Good there. And again, if you use a calculator, it's just going to be you do 17 first, then there's like this little plus minus thing, and it changes it to a negative. And then you can just say plus 35, and it gives you 18. 18 over 15. But again, this would not be the reduced answer. You now have to notice what does 15 and 18 have in common? 3. So now I'm going to divide the top and the bottom by 3. So 18 divided by 3 gives me 6. And then 15 divided by 3 is 5, which is exactly what the calculator told us as well. Did all the simplification. I'm good either way. Doing it by hand, doing it with a calculator, whatever you are comfortable with. I'm good. We good there? Absolutely. I'll put the next question over here so you get some more time. So question 6, more fractions, a little more intense on the fractions. 1/3 x plus 3/8 x plus 3/2 minus 3/4 x equals -3. Um, oh, number 5, it would be 6/5. Yeah. So, oh, yeah, we're not even done. Oh, I got so excited over here. I wasn't even done with the work. All right. So, yeah, so go back. We got 3/5 x equals 6/5. Thank you for that. I was like, this is not right. Yeah. Sorry about that. So now, what do I do to get rid of a fraction? Ooh, what did I do earlier to get rid of this fraction? Oh, I don't have it on here no more. I flip and multiply the reciprocal. So I'm going to multiply by 5/3. And then what I do to one side, I have to do to the other. So to get rid of fractions, we multiply by the reciprocal. And then now we can remultiply. So 6 times 5, 5 times 3. Simplify, what's 30 over 15? Ooh. Not quite. How many times does 15 go into 30? 2. Yeah. Yeah. Very good. That's a calculator. This is where the part here, because this is not where I want you to stress. This part calculator would do. The stressing is knowing what operations to do and when to do them. Let technology these days do that part for you. The test is hard enough without having to remember how to multiply and add fractions and stuff. All right, now we finished that one. So that one is 2. That's it. Now I got so excited over here. I was just didn't finish the problem. All right. So now we're going to combine like terms. But now when we combine on number 6 here, do y'all have time to write it? Oh, I know I got ahead of myself there. All right. So I need to combine 1/3 x, 3/8 x, and negative 3/4 x. We doing this by hand or by calculator? Let me show you both. Okay. I'm going to be honest with you. This one, I'm looking for a common denominator between 3, 8, and 4. Now, here's the misconception when I say common denominator. It is the smallest number that those 3 numbers can go into, not the smallest number that can go into those 3 numbers. So the best approach, and this is how I've taught it until you get the pattern, just go through your multiples. So if this is what 1 times these numbers were, B, what is 2 times these numbers? So meaning what's 2 times 3? 6. Not quite 8, so now we're going to go on a little bit further. 3 times 3, 9. Now it's bigger, so now I'm going to come over here and try to catch up. So 2 times 8, 16. Oh, now this one's bigger, so now I come back over here. 4 times 3, 5 times 3, 6 times 3, 18. Now it's bigger, so I come back over here. 3 times 8, 24. Then I come back over here. 7 times 3, 8 times 3, 24. That's perfect. Now we got to get this one there. 4 times 2, 8. 3 times 4, 4 times 4, 5 times 4, 6 times 4. There it is. So 24 would be my common denominator. So now the idea is, what do I have to multiply 3 to give me the 24? 8. But what I do to the bottom, I have to do to the top. Now we're going to go on to the next fraction. What do I have to multiply 8 to give me 24? 3. So what I do to the bottom, I have to do to the top. And I'm not worried about this fraction yet because I can't combine it. So now what do I have to multiply 4 to give me 24? 6. Again, what I do to the bottom, I have to do to the top. This is the best approach I've done so far with kids. In the past, I've done like least common denominator, getting a prime factorization, and kids are usually lost. This one seems to make the most sense. Are y'all okay with this way? The goal is just to figure out what the smallest number that they can all go into. So 3, 8, and 4 can all go into 24, but that would be the smallest one that they can all equally go into. Gotta love the 21st century taking notes. I remember my first year teaching, they're like, can we take a picture of this? I'm like, sure, I guess, yeah. I'll see what's wrong with it. Like, oh. All right, so now from there, now we got to do all this work. I want to bring it over here. 8 times 1, 8. 3 times 8, 24. There's my x. 3 times 3, 3 times 8. 6 times 3. That's a minus in it, minus 18. And then 6 times 4. All right, now that these are all the same, I know my answer will have a 24 on the bottom, and now I can just do the top. So 8 plus 9, 17. 17 minus 18, negative 1, x. Right, so I just combine this one, and this one. And now I'm going to write the rest of it down. So we go here. Again, when it comes to adding and subtracting, they have to be the same denominator. A lot of the students, they want to do 1/2 plus 1/3 and tell me the answer is 2/5. That's not how addition of fractions work. Okay. All right, so from here, what would be my next step back? Now that I've combined like terms, what do I need to do to get x by itself? Halves, perfect. So I need, since I'm adding, I need to subtract the negative 3/2. If it's easier to think about, you could technically type this as a decimal, and this is really negative 3 minus 1.5 if you're easy to go that direction. If not, a whole number can be a fraction by putting it under 1. And then now, what do I have to multiply 1 to make it a 2? 2. So if I do it to the bottom, I have to do it to the top. So negative 3 times 2 gives me negative 6. So it's a 6, and then we just apply the negative because different signs give us a difference. And then 1 times 2 is 2. So now that they have the same denominator, I know my answer will be a 2. And then now I can do the math. Negative 6 minus 3. Negative 9. In this case, you owe someone 6, borrow another 3. So now I get negative 9/2. Right? This time I'm not done because there's one more step. I'm not going to forget. What do I get rid? How do I get rid of that negative 1/24? How do I get rid of fractions when they're being multiplied? Reciprocal. Got to multiply by the reciprocal. So I got to flip it. So this is 24 over negative 1. And since I do it on this side, I got to come over here and do it to this side. Right? Now they're real fun. 9 times 24. 216? 216. So that'd be negative 216. Because again, different signs, get a different sign. 2 times negative 1, just negative 2. 2 times 1 is 2. Different signs, get a different sign. Now, this is now a division problem. What is negative 216 divided by negative 2? Ooh, no. So we'll break it up in here. Here's 216. Here's a 2. 2 goes into 2 how many times? 1. And then can't go into that. So then 2 goes into 16. 8. So close. Just lost the 0 in the middle. So it'd be 108 But what would the sign be if I'm dividing two negatives? Positive. Same sign gives you a positive answer. Absolutely. I said, don't stress about the small things. The big things are coming. I don't want y'all stressing about the adding, subtracting, multiplying, dividing. That's not what this class is about. Your 0300 class, the class before this, is more stressed on that, but not this one. We got to understand the linear concepts. All right, you ready? Got one more question in 9.2, and then we'll move on to 9.3. So number 7, we have some fractions still. So 2/3 x minus 5/9 equals 1/18. What would I do first here? Perfect. Get rid of that addition and subtraction. We might be dealing with fractions, but the process does not change. All right, so how do I make the smaller number become the big number? So how do I get by 2, right? How do I get 9 to be 18? I multiply by 2. If I do it to the bottom, got to make sure to do it to the top. Perfect. So 5 times 2, 10. And then 9 times 2, 18. So now I know my answer will have an 18 on the bottom. I can do the actual operation. So 1 plus 10, 11. All right, so I'm going to ask it again. What do I do next? I'm going to multiply by the reciprocal. I see a fraction, so I'm going to multiply by its reciprocal. And what's the reciprocal of 2/3? 3/2. But of course, what I do to one side, I must always do to the other. Multiply straight across. 3 times 11. 2 times 18. Do these two numbers have anything in common? 3. So I'm going to divide them both by 3. 33 divided by 3. And then, oh, I was about to say, is that about to be 18 again? Okay, yeah, sorry. Yeah, 12. Yeah, 12. Yeah. So 11/12. In my head, I don't know why, but I guess I was dividing by 2, and I was like, 11/18. What are we? What's the same result coming out? And there you go. So, any questions on 9.2? All right, do y'all need another break, or do y'all want to go right into 9.3? Okay. Yeah, my goal is to get through at least 9.4 because I'll give us 4 sections a day, 3 sections on Wednesday, and then maybe we can have some homework time on Wednesday. Y'all can get into Hawks Learning, ask questions, and have that one-on-one too if we need some. At least that's the goal. We'll see. Homework's already open. It's due next Sunday, so you got 2